We're starting a new unit on system of equations, and so your unit essential question is just simply going to be how can I demonstrate knowledge of finding solutions to system of equations. Alright, in part one of this, we're just going to cover just a couple different things. First question I want to ask is how many solutions can there be when I'm talking about system of equations? Well, the one thing I want to look at is if I look at this one, there's one intersection. So in this case, there's going to be one solution. There's one coordinate pair where they meet together, the two lines intersect, so it's going to be one solution. Here, when you look and you have parallel lines, when you actually graph both of your equations, there's going to be absolutely no solution here. That's the thing to remember, there's no solution. And once we actually graph both lines, and here it actually looks like there's just one line, but there's actually two lines. But they're the exact same line. This is going to be infinite solution. So they're going to be the exact same. This is just important to keep in mind as we actually start graphing the equations, and you'll see these different scenarios pop up. But in part one, here's the things I want to look at. How can I use graphing to generate the solution of a set of equations that are in slope-intercept form? We're just going to work two or three of these, and then I'm going to give you some assignment to do actually in class, and we're going to think, pair, share, and do some things with it. Just kind of take our time. But when I look at this and I see system of equations simply means there's more than one equation. So there's a set of equations. So here, if I look at this, it's the same thing we've been doing with linear equations, except there's two. And so let's just break this down into just two pieces. So I have two different equations. We'll say that's my first one. We'll change color. Here's my first equation. This is my second one. So all we need to do is just simply graph one of them at a time. Y equals x plus 2. Okay, if you remember here, that's my slope-intercept form. This is going to be my slope. My slope would be 1. My y-intercept is going to be a positive 2. So remember, I want to start by graphing my y-intercept. So I'll go over here and I'm going to go up to 2. Plot that point, because that tells me, okay, my y-intercept is going to intersect this y-axis at 2. Okay, if my slope is 1, it's x understood to be a 1 there. If you want, you can put the 1, makes no difference. And then I can just start going up 1 over 1, because it's going to be over 1, up 1, over 1, up 1, over 1. And then I can go down 1 because that's negative, but then I have to go negative again to make it positive. Now, I've graphed that one. And so this one, I don't have to worry about right now. Let's change colors here. And look at the second equation and just graph it. I have here a slope of 3, because I always want to look at what's next to that x. Y equals mx, m being your slope, then minus 2. Negative 2 being my y-intercept. So here we go. I go back over to my graph, go down to 2, negative 2 here, and I know my slope is 3. That means I have to go up 3. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. Now, it's important here that I go back and put my actual lines in to be able to see exactly what's going on here. So I put that one, and then I can do this, and I can change colors. And I'm going to look at my other one, and I see that there's an intersection here. Well, all I have to do is, okay, what is the coordinate pair where they intersect? And that's going to be my solution. So when I go back over, remember I'm doing coordinate pairs, so I can go over 1, 2. So my x value is going to be 2. And then I go up 1, 2, 3, 4. So in this case, the solution to this system is 2, 4. X value of 2, y 4. That's where they intersect. Alright, let's look at this one. Now, I mean, it has a fraction, but that's no big deal. No big deal. So here, let's look at the first one. Again, we're not going to look at both of them as one big gigantic one. Let's just break it apart. We graph the first one first. Again, I look at my y-intercept. It's -6, so I can start here. Go down. 1, 2, 3, 4, 5, 6. -6. And I know my slope is 1/2. That means I have to go rise 1 and run 2. Not run 2, or not run 1, but rise. Up 1 over 2. Positive, positive, positive 1, 1, 2. Up 1 over 2. And then I can go down 1 and back over 2, and I'll go one more time. And I'm just going to connect my line. So here, again, now let me go back and let's do the other one. We have graphed this one. All we have to do now is just go back and graph the other one. And it is just simply 1/2 x. Well, if I don't have a y-intercept, that tells me I just need to start at 0, 0. There is no y-intercept. So here, I know my slope again, it's just 1/2. I go up 1 over 2. I'm going to go ahead and mark 0, 0. Up 1 over 2. But then I'm going to go back. And I already start to notice something about this. These lines, they're not going to intersect. So that tells me I have something here, a different type of problem. Again, if I go back to the organizer we looked at the very beginning, when I have two parallel lines, what that means, it just simply means there's not going to be a solution because there's not going to be any points of intersection. They're parallel and they're going to go on and on forever and never ever intersect. So whether you have fractions or whatever, don't let this fool you, don't let this trick you. Just keep your rise over run and you're in good shape.